Hi, this is your host. I recently got asked what would happen if all rivers ran backwards. And at first I thought this was a stupid question because it's obvious what would happen. The oceans would fill up with water, but then I thought, no, actually that's not true. You can't just reverse a river without also reversing the ocean it empties into. So then I thought, well, the water would just kind of stay where it is. But then I thought, no, actually all the fish would die. And then I thought, no, actually they wouldn't. And then I realized this question is surprisingly complicated to answer properly. Before we begin, we have to settle a matter of semantics. When we say a river reverses, do we mean the flow of the water or do we mean the river itself physically reverses direction? For example, does the Nile continue to be the Nile if it flows north instead of south? I'm going to assume that we mean the flow of the water in each river individually reverses, but that the rivers themselves don't get rerouted. If that is the case, there are two things that need to happen. First, the water has to go backwards. Second, the net movement of water from the rivers into the oceans needs to be zero. On average, about 97% of Earth's fresh water is stored in oceans. This means that for every 100 units of water in the hydrosphere, only 3 units are in rivers. On average, rivers transport about half of their volume of water back to the ocean. That means if we reverse the rivers, the oceans won't fill up with water, but we'll need to account for the other half. Also, we have to account for the fact that some rivers gain or lose water as they make their way to the sea. So let's look at an example. The Rio Grande starts in Colorado and empties into the Gulf of Mexico. In the section of the Rio Grande between these 2 points, it gains about 20 cubic kilometers of water per year from tributaries and groundwater. It also loses about 8 cubic kilometers to evaporation and human diversions. Instead of gaining 20 cubic kilometers of water from tributaries north of this section, it'll lose that amount. And since the river will now be flowing northward, it'll probably lose less to evaporation. Still, the overall change won't be huge. So, for the purpose of this exercise, let's just assume that for every 100 units of water entering the Gulf from the Rio Grande, 47 come from the river itself, and 53 came from somewhere else. Now, keep that 53 in mind. We're going to come back to it. But first, let's tackle the first part of our problem. To reverse a river, you need to reverse the forces that drive the river's current. The most important of these forces is gravity. Since the Earth is round, gravity pulls everything towards its center. Water is no exception. This means that water always tends to flow downhill. And while the slope of a river isn't steep, over the course of hundreds or thousands of kilometers, it does add up. Over its entire length, this makes the river about 60 meters deeper near London than it is at its source. The slope of the river is what causes water to flow from the relatively high elevation at the source to the relatively low elevation at the mouth. Reversing the direction of gravity would require changing the shape of the planet. And while this might be possible in principle, it isn't possible in practice. So let's stick with our original gravity for now. The next major force acting on rivers is the Coriolis effect. This is caused by Earth's rotation, and it deflects moving objects to the right in the northern hemisphere and to the left in the southern hemisphere. The Coriolis effect is most pronounced on large bodies of water, and it has a significant impact on ocean currents. But on small bodies of water like rivers, it's usually negligible. In general, the Coriolis effect depends on both the size of the body of water and the speed of the rotation. As a result, it has a greater impact on rivers at higher latitudes where Earth's rotational speed is faster. For example, the Coriolis effect is important for the rotation of large Rossby waves in the Gulf Stream, which form at about 60 degrees north latitude. On the other hand, the Coriolis effect is completely negligible for the rotation of small Taylor columns in rivers, which form closer to the equator. So reversing the Coriolis effect wouldn't really change anything. Finally, we come to the issue of friction. Friction slows down the flow of water in rivers, and it becomes more important the faster the water is flowing. This means that in general, friction plays a larger role in wide rivers than in narrow ones. To see why this is, consider two equally long but differently wide rivers. They both have the same slope, so gravity is pulling the water downstream with the same force. However, due to friction with the riverbed and the banks, the water in the wider river slows down more when it reaches the end. This means that friction plays a larger role in the wider river. If we were to reverse the rivers, you'd essentially need to add an extra force to the water equal to the frictional force in order for the water to flow back upstream. This force would have to be greater the wider the river is because friction is greater. So, how exactly would we do that? Well, one way would be to increase the slope of the river. This would increase the gravitational pull on the water until it is strong enough to overcome the frictional force opposing the flow. Alternatively, we could decrease the friction, such as by somehow magically increasing the width of the river. In either case, we would need a mechanism to redistribute the energy lost to friction. Ultimately, though, there is no way to truly reverse the frictional effects on a river. Some energy will always be lost to friction, and some force will always be required to overcome this. So it turns out that reversing a river isn't really possible. The best we can do is build something like a weir or a dam to slow down the flow of water moving downstream. But even then, some water will still leak through. So, to answer the original question, what would happen if all rivers reversed? Well, nothing really. If we could somehow reverse the gravitational pull of Earth, then we could theoretically reverse the flow of rivers. But since we can't, the frictional forces acting on the water will prevent it from fully flowing upstream. So the flow of most rivers will continue in the same direction as before, although it might slow down a little bit. The notable exception to this will be rivers near the poles, such as the Rio Grande and the Mackenzie River, which flow almost entirely within the same hemisphere. In those cases, the Coriolis effect might be enough to reverse the flow of the rivers. But again, the frictional forces acting on the water will prevent it from fully flowing upstream. As a result, the volume of water in the oceans will hardly change. For example, the Congo River crosses the equator twice. So while technically it flows north, about half of its water originates from the southern hemisphere. Okay, but what about the fish? Fish use various mechanisms to navigate in rivers, such as by sensing changes in water temperature, pressure, oxygen levels, and even electric fields. Changes in these variables often occur gradually over distance. As a result, fish can sometimes detect them and adjust their swimming accordingly. Other times, though, fish need to respond quickly to sudden changes. Take, for example, a fish trying to swim against a wave. In situations like these, fish rely on inertial navigation, basically by feeling the drag caused by the water and adjusting their swimming accordingly. There are some animals that are able to sense the Coriolis effect. Bacteria, for example, can adjust their flagella orientation in response to Earth's rotation. But this doesn't seem to be related to Earth's gravity. So we expect the Coriolis effect to have a minimal impact on the behavior of fish in rivers. On the other hand, friction is something that lots of animals have had to deal with throughout evolution. In the case of fish, adaptations include streamlined bodies, flexible fins, and powerful tails. If we were to suddenly decrease the frictional forces acting on fish, we would throw off these adaptations, and as a result, fish would probably be less efficient swimmers. In other words, their ability to swim against the current would get worse. Now, whether this would be lethal for the fish would depend on several factors, including the species of the fish, the river in question, and how quickly the transition takes place. But ultimately, we can't rule out the possibility that many fish would die. In conclusion, if all rivers reversed, we would see a redistribution of water between the northern and southern hemispheres, but the change would be so small it would be unnoticeable. The frictional forces present in the rivers would prevent the water from fully flowing upstream, and some fish would likely die. However, life would probably go on as usual. Thank you for watching, and let me know in the comments what you want to hear next.